Hello, everybody. So, as you told me, the recording of Wednesday lecture was not clear. So I'm recording the lecture again. Hopefully, this time it will be better. Actually, I don't know what happened last time. I used the same mic, same computer, everything was the same, but that's okay. I can repeat the lecture again. So, here, guys, let me quickly remind you what I did. Okay, let me make it, just give me 1 second. Yeah. Okay. So what I told you guys before, that our microcontroller has a number of input-output devices, as you see here. Okay, input-output ports. So, for example, we have port B, we have port H, port E, and so on. So we have a number of ports here, guys. As I told you, if you want to connect any input-output device, you have to connect it to a port. That's why in this chapter, when I told you before this chapter, in this chapter, I'm going to explain to you how can you program a number of devices. Let me just, yeah. So here in this board, guys, we have a number of input-output devices. So this is, port H is input. We have 7 segment, LEDs are output, LCDs output. So before I teach how can you program any of these devices, I'm going to tell you first how they are connected to which ports, as I told you. So as I told you guys, every port, as we see here, has external pins. This is where you connect the input-output device. Also, every port should have a number of registers. One register, we call it data direction register, as I said last time, as I said before. This one is used to configure the port input or output, okay? So if you want to configure a pin in a port, input or output, all what you have to do, you have to put one in the corresponding bit in this register, okay? If you want to configure it input, you have to put 0, okay? After you program it input or output, and after that you can use the port. This configuration should be done at only one time in your program, and that's it. Once you configure it, that's it. Okay. After that, you can if you want to read a port, you have to read the data register. If you want to write to the port, you have to write to the data register, as I explained before. So last time, or on Wednesday, I was teaching how can you program LEDs. If you look at the board here, guys, we have 8 LEDs which are here. These LEDs are connected to port B, okay, as we see here. So these LEDs are connected to port B, okay. Also, and then this is the anode. So you know, for LEDs, we have anode and we have cathode. This is anode and cathode, okay? This is for LED. And in order to turn the LED on, so the voltage of the anode has to be greater than the voltage of the cathode, okay? Otherwise, it's going to be off, okay? And then you can see here, we connected all the cathodes together to BG1. When you see BG1, this means port J, pin number 1, okay? Why we did this way? As I said before, let me write it here. So if you put here, okay, so sorry, let's select the color. If you put here 0 volt, logic 0, okay. So now this is port B. If you put here 1, logic 1 or 5 volt, so the LED is on. If you put 0 volt, the LED is off. So now the LEDs are working, right? So I told you before, this one can be used as enable or disable to the 7 segment. If you put 0 volt here, you actually enable the LEDs. That means you can turn them on and off, okay? So, however, let me clear this one. However, if you put here 5 volt, so if we put here 5 volt, so you actually disable the 7 segment. Why? Because when you put your 5 volt, guys, If there is 5 volt here, it is off. Why? Because I told you to be on, the anode has to, anode has to be, this is the anode, cathode. Anode has to be greater than the cathode, but this is 5 and 5, so it is off. Even if I put 0 volt, nothing as well, because the anode has to be greater. So the conclusion is we use BG1 here, guys, in order to enable or disable the 7 segment. So if you put here 0 volt, so now you can use the 7 segment, so you can turn on and off. Sorry, the LED is not 7 segment. So if I put here 0 volt, that means you can turn on and off any LED. However, if you put here 5 volt, so they are disabled. Okay, so why we did this way, as I told you before, this is simply because the way the board is designed and is we have port B. For port B, I'm going to connect LEDs. I'm going to also connect, or this is how it is. It's connected. LEDs are connected, and also 7 segment. The 7 segment are also connected to port B. And everyone, let me come here. Look here, guys. So here, if you want to use the LEDs, it has enable, which is BG1, right? So you have to put 0 BG1 for this one to work. We have 4, as you see here, we have 4 7 segment. So this one has PP0, PB1, PB2, PB3. Okay. So this is the pin that used to enable it. Okay. Same thing. If you put here 0, for sure, I didn't explain yet 7 segment. I'm going to explain later. But I just want to justify why we have BG1 here. We have BG1 because to enable or disable the LEDs. Okay. So also here, if you want to use this 7 segment, you have to put 0 here. Or if you want to use this one, you have to put 0 here. Or you have to use this one, you have to put 0 here. Usually what we are going to do, only one of them is going to be on, enable, and the other will be disabled. Okay. So for example, if I want to use the LEDs, I'm going to put 0 here in BG1, and then I'm going to put 1 in PB0, 1 in PB1, 1 in PB2, and PB3 as well. So everything is off except this one. Okay. Same thing, if you want to use one 7 segment, so I'm going to put here 0 to enable this one, and then I'm going to put here 1, so everyone is disabled. Okay. I told you this is how they did it this way because they made this board for education. So they put a lot of stuff on the board. When you do your own design, you don't need to do something like that. However, I feel it's interesting to learn how can you enable or disable some devices. It's also an interesting idea. Okay. So and then as you see here, the LEDs are connected to port B, right? So every pin in port B is connected to one LED. You can connect it on, you can turn it on and off for sure if they are enabled. Okay, so now here in this program, I wanna teach flashing LED. What this means, I want to turn the LED on for 1 second and then off for 1 second, on for 1 second, off for 1 second. So here I'm telling you the steps we have to do. Number 1, and this is what we are going to do all the time, guys. Okay, so before you use any port, you have to configure this port. Okay, I don't want to keep repeating it, but this is how it is. Okay, so any port we are going to use, you have to configure it, input or output. In this case, it's output. Okay, so here this number 1, you have to configure them. You have to enable BG1, as I said, by pull it low by putting 0. Also, you have to disable the 7 segment. How can you disable the 7 segment? As I told you, we have PP0 to PB3. You have to put ones in them. And then most of the time your program should be here. So this is just a configuration, should be done only one time at the beginning of your program. So most of the time your program will be here, guys. Okay, so number 1, you are gonna pull PP0 high, as you see here. Then I'm gonna wait 1 second, and then I'm gonna pull it low, as you see here. I'm gonna wait 1 second, and then I'm gonna keep repeating this way. Is that okay? So you can see, guys, from here to here, it takes around 2 seconds, right? 1 second high, 1 second low. In other words, what I did right now, it is like that's what I did. I generated a square wave. So in every iteration, I'm going to generate 1 cycle. this way. So this is one iteration. Next iteration, I'm going to generate another cycle and so on. Okay, so all the time I'm going to go back and run it this way. Okay, so now this is the code. Here I'm just it's like pseudo code, or I'm explaining how we do it. Now I'm gonna show the program. So this is the program. This is if you look at the beginning here, this is what I told you. You have to configure port J output, right? How can BG1, not the whole. I'm only using BG1, not the whole port. Okay. To do that, all what I have to do, I have to just data direction register J. So here in bit number 1, remember we have bit number 0, so we have 0 1, right? So here I have to put 1 because 1 means output. That's what I did. I said bit set DDRJ and then 2. 2 is actually 0 1 0 0 0 0 0 0. So here I wanna set this bit. Okay. So this is number 1. Number 2, what other ports you are using? I'm using port B. Yes. So here I'm using, again, I'm not using the whole port. I'm just using one pin. So what I did here, bit set, also bit set for, and then this is data direction register for port B. And then I put one here for PB0. Okay, guys. So I'm going to make it easy. So now these are output ports. That's why I'm using bit set, guys, because if you put 1 in the data direction, you make this port output. Okay. However, if you put 0, you make it input. So in case of in case of input devices, I'm gonna, instead of using bit set, we are gonna use bit clear. Okay. But for now, we're only using output in this example, in this program. What else? So now I programmed data direction register for port J, with data direction register for port B. What else? I'm also using port P, right? So here port B. So here I put 1 in port P. Okay. So these 3 instructions, this one and this one, just for configuration of the ports. After I configure the ports, guys, now as I told you, LEDs and the 4/7 second are connected to port B. Only one of them should be on at a time. Okay. What if you forget and more than one is on? Okay, all of them are gonna run, so you're gonna see something, but it's gonna be like random shapes on the 7 segment. It's not gonna burn out the board, so it should be okay. However, it just doesn't make sense. Okay, so here, so now in order, I wanna turn the LEDs on. Okay, how I can do that? So I have, as I told you, I have to write 0 on BG1, and that's what I did here. Okay, bit clear BTJ02. So here I'm writing 0 to BG1. Again, guys, don't be confused between this one and this one, please. This one for direction. This one is used to configure the port input or output. This is the port itself. Okay, this is the port itself. You read or write to the port. Here, so this is, here I enable LEDs. Okay, I have to disable the 7 segment. How I can disable the 7 segments? As I told you, we have PB0 to PB3. We have to write once, and that's what I did here. I wrote once here. Okay, so this part is just the configuration, guys. Okay, and most of the time the program is here. Okay, so let's see how the program works. Number 1, I have to pull the pin high in order to turn the LED on. Okay, so so I can do this way. I can say bit set port B and then 00001 because I want to turn this pin on. I want to turn the I want to put 5. I want to turn this LED on. In other words, I want to put 5 volt on this pin PB0. Okay, so I'm gonna pull it high. So after you execute this instruction, the LED is on, and then I'm gonna wait 1 second. So using these 2 instructions, I'm gonna wait 1 second. Then I'm gonna turn it off. So if you look at this instruction, guys, is similar to this example, this instruction, but this one is bit set, here bit clear in order to write 0 on PB0. 0. Okay, so here I turn it off, and then I'm gonna wait 1 second, and then I'm gonna go back to repeat again. So you can see here, guys, in every cycle, pull high, wait 1 second, pull low, wait 1 second, and then go and repeat again. Okay, so now the question is that how can we wait 1 second? Actually, the way we made it, we created a function. This function is called the delay y millisecond. Y is register y. Okay, so this function should make a delay which is equivalent to the value stored in register y in millisecond. Okay, so in order to make a delay 1 second, so I have to write 1000 in y, in register y, and then I call the function. Once you do that, this function is gonna wait 1000 milliseconds. Okay, as I told you, 1000 milliseconds for sure it is 1 second. So once you go to the function, you are gonna wait there. You are gonna wait in the function for 1000 millisecond. Okay, then you are gonna come back after 1 second. You can change this number if you wanna. Here in this program, I wanna make flashing every 1 second. So turn on for 1 second, off for 1 second. However, you can easily change it if you want. You just change this number, right? Anyway, so let me same thing here, guys. Okay, so for example, if I put here 500, so by this way I'm gonna make and 500 here as well. By this way I'm gonna make the flashing faster. So turn on half a second, off half a second, or you can make it 250, quarter a second, and so you can easily change the speed of the flashing. Okay, by changing the numbers here. So how let's look at this function, how this function works. So the idea of this is the function, guys. It's called the delay y millisecond. Okay, so this is the idea of the function. Let me tell you the idea. The idea, once I come here, I'm gonna execute some instructions. Okay, you know, as I explained in chapter 2. Every instruction has a time, execution time, okay? So I'm going to execute some instruction. Actually, they are not doing anything. As a functionality, they are not doing anything. I'm just wasting time, okay? So if you see here, guys, push, pull, nothing, right? I push, pull, push, pull, push, pull, push, pull. I'm not doing anything. I'm just wasting time because to execute time here, I'm creating a delay. So to execute this one, it's going to take 2 cycles, as I explained before. This one, 3 cycles, and so on. Okay, guys? So if you count how many cycles we have from here to here, it is 24 cycles. Okay? And as I told you before, our clock is 24 megahertz. 24 megahertz. That means, let me write it here. That means the time of each cycle should take 1 over 24 megahertz, which should equal 1 over 24 microsecond. Is that okay? So every 1 cycle is going to take 1 over 24 microsecond. Okay. So what about 24 cycle? They should take 1 microsecond. Okay. That means our microcontroller can execute this instruction. This one, 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 and this one in 1 microsecond. Okay. Look how it is fast, very fast, right? It can execute all this instruction from here all the way to here, all this instruction just in 1 microsecond. Okay, guys. So anyway, so I made some instruction that can make 24 cycles. They are not doing anything. I'm just wasting time, so that the execution time from here to here is 1 microsecond. Okay, guys. And then if I repeat this part 1,000 times, if I repeat this part 1,000 times, okay, that's why I created a loop here. Can you see, guys? So this is 1,000, and this is decrement and branch of not equal. So I'm going to go through this part. I'm going to repeat this part 1,000 times. So every iteration is going to take 1 microsecond. If I repeat it 1,000 times, by this way I can make 1 millisecond. Okay. So these instructions, in order to make just 1 millisecond, guys, I have to execute these instructions 1,000 times. Okay. So now that means let me clear it again. That means from here to here, guys, from here to here, it's going to take 1 millisecond. This part is going to take 1 millisecond. That's okay. So the question is, how many milliseconds we want to make? As I told you before, it is y millisecond. Okay, so this part is 1 millisecond. So in order to make y millisecond, I'm going to repeat this part y times, as you see here. So I'm going to say decrement and branch not equal. For y, go to here. So I'm going to come to here, from here to here. How many times? Y times. And every time it's going to take around 1 millisecond. Okay, this is how I created a function to create a delay for y millisecond. Okay, guys, I want to tell you something. You should have already noticed that this delay is not very accurate. Okay, because to make the calculation simple, I ignored some instruction. For example, I didn't calculate this instruction, right? I didn't calculate ball X. I didn't calculate RTS. Even if I go back here, I didn't calculate jump instruction. I didn't even calculate this one. But it should be okay because this instruction takes very little time. Okay, guys? So what I'm saying is that, yes, it is not very accurate, but for 1 second, it should be okay because if you have, this instruction takes I told you, if you have 24 cycles, it's going to take only 1 microsecond. All the instruction I explained, I don't think they are going to take 24 cycles. I don't think it's less. Assume in the worst case it is 24 cycles. So you are going to have error 1 microsecond. So that means if you need 1 second, you are going to get 1.00000001. You got what I'm saying? So it's almost nothing. Just to make the calculation easy. For sure, if in some application, here in this application, may not make, it's not a big difference. If you have 1 microsecond in accuracy, it's just very little, it should be okay. However, maybe in other applications, if you need something very accurate, in this case, you have to count everything. So it's going to be like little bit computation more complicated. Okay, guys. Using the same idea, I created a function. This function is called delay y microsecond, as you see here. It's the same idea. So here, from here, the only thing I did, as I explained here, guys, I created 1 microsecond, right? And then I looped around it y times. Okay. So I'm gonna do the same thing, but instead of creating 1 millisecond, I'm gonna make 1 microsecond and loop around it. So that's what I did here. So here, delay y US microsecond. Okay. So here, from here to here, it is 24 cycles. So I'm gonna repeat this part y times, as you see here, y times. By this way, I can create y milliseconds. So actually, this program is similar to this function. I just removed this 1,000 iteration. This one, okay, guys. So it's using the same idea. The other, so if you connect PP0 to the scope, you will see a square wave like this one, guys. Okay, from here to here it is 1 second. From here to here it is 1 second, 1 second, and so on. Okay. The next thing I want to explain, guys, in this chapter, I'm going to explain several subroutines in assembly. We can just use these subroutines. You don't need to in order to make programming easier. I put all these subroutines in a file. This file is called. Let me show you. Yeah. So this file is called subroutine.include, right? So and this I put this file on the course website with the program. So all the, I forgot to tell you, all these programs, guys, are already on the course website. This is the name of the program right here. I put the name of the program. You can find all of them on the course website. So with this program, you will find I put include file. This include file has all the subroutine we will use in assembly. Why it's a very good idea to do that? Why? Because I want to make it easy for you. So you don't need to copy and paste. And when you copy and paste, you may make error or something like that. You don't need to copy and paste. All what you have to do for any program I'm going to teach, you can just include this file, and then you can use any subroutine. It's already a new program. You don't need to copy and paste. Very interesting idea. Okay. So as I told you, we have a several subroutines I'm going to teach. I already explained 2 of them. I explained delay y microsecond and delay y millisecond. Okay. In this chapter, I'm going to teach more. Like for example, here put a string to LCD. This one is used if you want to write to the LCD, keypad, and so on. Put character to LCD. So I'm going to teach you more subroutines again to make the programming easier. All these subroutines are already in this file. Let me open this file to show to you. It's already on the course website. So let me open it here. So this is the subroutine is here, guys. So if you open it here, yeah. Sorry, I think I opened the wrong file. I'm sorry, not this one. This is a file we include every time here. So I think I opened the wrong one. So let me open the correct one here. Yes, here it is in programs. So you already have these programs in the course website. So under assembly, you will find something that's called subroutine.include. Yeah, so you can see here, guys, if you open this file, you see all the functions I'm going to teach. They already here. Okay, so now the question is, how can you include this file in your project so that you can use it without, when you use it, you don't need to worry about copy and paste. You don't need to copy and paste. Okay, so the question is, how can you include it in your file and just use it? Okay, to make it easy for you, I made a tutorial online. Yeah, so you'll find this file online, tutorial on how can use subroutine this file. Okay, so you will see, first of all, guys, before you include it, you have to put this file in your project. This file is not coming with code warrior. So once you open your project, you are not going to find it there. You have to put it, right? Because I'm the one who created this file. So where you have to put it, when you open your project, guys, you see something like include here, includes, right? And this includes, you see, this is a file we include all the time, right? Msc9s, whatever. This is the one we include all the time. We put it here, okay? So you have to put the file here. So you have to locate the file on your hard disk and you put it in your project. Again, why you have to do that, guys? Because this file is not coming with code warrior. So if you just use it, code warrior is going to give you error. It's going to tell you, where is this file? I don't know where is it, okay? So all that you have to do, you have to come to include here, guys, in your project, right click, and then select add files, okay? And then after you select add file, now you can locate the file in your hard disk as I did here, and then you click open. Once you do that, guys, you should see the file here. Very easy, right? So now the file is included in your project. Again, if you don't see the file here, that means you didn't include the file. That means when you use it, you are gonna get error. You are gonna get error because code warrior doesn't know where is this file. So now the file is included here, right? So the file is already in my project. Now I have to include it. I have to write an instruction like this one, include in my code, right? So now the question is, and maybe you are gonna be confused here. Please listen to me. Look here, guys. What is the content of this file? Okay, sorry, let me. So what is the content of this file? Okay, this file it has code, so you have to put it in the code area. So by the end of your program, by the end of your code, you have to include this file. Is that okay? Someone can tell me, but when we did this one, we put this one in a different place, this file here. Yes, when we included this file, we put it here. You know why? Because this file has equate, okay? And equate should come at the very beginning of your program. That's why you included this one here. Be careful, please, guys, okay? So don't be confused. I used the same statement, include. However, I put this one, this file here that has a lot of equate instruction. I put it here in the beginning of my program, but subroutines, I put it in the code area at the end of your program, but because this is like a code, so it has to be here. You know, when you include a file, it's like copy and paste, something like that. So it's like you copy and paste it here. Everything will be here. Okay, guys? This is one thing you have to do. Okay? There is another thing you should do, guys, that in this file, in subroutine.include, I'm using a byte. So you have to define a byte. It's called counter ds.b1, right? So you have to define this one because it is used in the subroutines here. Okay, even if you don't use it, it's already in the subroutines. Okay, if you forget to do that, you are going to receive error from the code error. The code error is going to tell you are using a variable called counter, but you didn't define it. Okay, you may be confused because you didn't use it, but it's already here in subroutines, right? So you didn't write it, but it's already in the subroutine. So also what you have to do, guys, you have to define here a variable. It's called counter ds.b in the data area. Okay. Anyway, so you have this tutorial, guys. You can just look at it again and once you do it in the lab, one time you will understand. But it's again, this is a very good idea, guys, because it's going to save a lot of time, a lot of effort. You don't need to copy and paste subroutines. You just include the file and then you use all the subroutines. Okay. Now I'm going to move to C language. I want to teach how can you do the same thing like flashing LEDs this way using C language. But before I do that, let me choose a video here. Have a video here. Let me share computer sound. Okay, so I want to show you the program, this program here.
It's only for 1 second.
So what I'm going to do is I'm going to make the delay 1 second and 1 second, and then I'm going to see what's going to happen, and then I'm going to play. I'm going to just change this number and see what should.
So let's start. This is a board. Okay, so let's run the program. Look here, look at the LED. It is on for 1 second and it is off.
And you see the flashing, it's on for 1 second, off for 1 second. Okay. Again, you have the board, you have the programs, you can try them in home, and then you can modify them if you want. It's a good idea to just play. It's very interesting to do that. That's what I'm going to do right now. So now I'm going to change the time from 1 second. I'm going to make it half a second or a quarter a second and see what's going to happen. Okay, so that's what we do.
For 1 second. Turn off. Here, that's what I want to do. 500. So the time now is going to be half a second. Well, let's see this one.
So as you see, I made it 500 millisecond, okay, for delay, which is half a second.
Yes, let's run it. Okay, look here. It's only half a second. Is that fine? Okay, now.
Okay, so you can see the flashing is faster now. Okay, look here, guys. Try to think about it. If I make this delay very, very small, like for example, 1 millisecond, 5 millisecond, what do you think? What can you see? Okay, do you think it can your eyes can see flashing every 1 millisecond, every 5 millisecond, which is a very little time? I'm asking, right? Not only that, do you think the device itself, if you make the flashing very fast, do you think the device itself can turn on and off that fast? Okay, so let's see. I'm trying, I'm playing, so let's see what.
Let me think, what about if we can make, so it's gonna be only 1 second.
1 millisecond, guys, and 1 millisecond.
Sorry, 1 millisecond.
And let's see what's gonna happen, okay?
Very short time. Oh yeah, we have to restart.
So when I did it, guys, you can see here, you can see it is very stable. It's on all the time. It's very stable. It's almost on all the time. You got what I'm saying? Again, that's because number one, the device cannot turn on and off that fast. Number two, even your eyes even cannot capture this is very high speed. So you can see it like it is like very stable. It's like on all the time. However, it's not on all the time, right? But I'm doing it very fast. On off very fast. Okay, guys. So now I'm gonna explain now how can we do the same thing using C language. Okay. So for C language, before I started, before I start C language, guys, number one, I created a tutorial on the course website also. It's a review, not tutorial, sorry, it's a review on C language. Okay, so I did a review on C language. You should already have taken a course in C language. However, I know maybe some of you forgot it. So what I'm gonna do, I already created here a review, and what I'm gonna do every time I teach C language, I'm gonna explain how it works, just to make like a refreshment. So here, let me, yeah. So that's what I'm gonna do right now, guys. So I'm gonna teach some operators what we need in C language. The first thing I'm gonna teach in C language, bitwise operators. You know what I mean by bitwise, bit by bit, okay, by bit operators. So in C language, or these operators are used for bit manipulation, okay. Like here, one ampersand. This one is used if you want to do logic AND, bit by bit AND. This one is for to do OR, bit by bit OR. This one for XOR, bit by bit XOR. This one for one's complement. Is that okay? This one for shift right shift. This one for shift left. Okay. So now I'm going to give you example. How can you use this operator similar to what we did in assembly? Let's start with AND. Okay. Remember, I told you before, AND is used if you want to clear some bits. Okay, I said it before. I explained it in C language, and the same thing we're going to do right now. How can you do that? I'm going to tell you how. So if this is a port or a byte or whatever, okay, and then I want to clear this one, I want to clear this bit, and I don't want to change the other bits. I told you how can you do it. I'm going to put here 0, and then I'm going to put here 1, 1, 1. 1, 1, 1, 1, and then I'm going to use AND operation. Why you did this way? Because 0 and any bit is 0, right? But 1 should not change the bits. So all these bits are going to come here. So by this way, what I got here, I got the same byte like this one. I got it here, but the first bit is cleared. Is that okay? So that's what you are going to do. If you want to turn the LED off, you have to clear this bit. And that's what I did here. So look here, guys, what I did. I said, port B, and yes, in C language, you can use the same name of ports, data direction register, same name. Okay, so I'm here, you don't need to define them. It's already in the, I'm going to explain, it's already there. So you can just say port B equal port B, right? So this is the new value for port B equals the old value or the current value, and this one and this number, okay? This number is, here, it is 11111110. Okay, so that means this instruction is used if you want to clear bit 0. But someone can ask me, what is 0x here? You are not familiar with it. I'm going to tell you what is this. Okay, so if I come here, guys, if you look here, guys, if you have similar to C language assembly, sorry, if you write just a number here, if you put 0x as you see here, so that means this number is hexadecimal. So 0x here is similar to $sign we are using in assembly. And also, if you use 0p, so this is similar to percent we are using in assembly. That means this number is binary. If you don't put any prefix, so this number is decimal. So what I did here, guys, is this number is in hexadecimal, and this is logic AND, okay, bit by bit. So you can write it this way, and in C language you can also do it this way. So this one and this one are exactly the same thing, but this one is like compact. Again, if this one is easier for you, you can use it all the time, but you should know it can be also written this way. Okay, so this is the instruction we are going to use right now, guys, in order to turn the LED off, right? So now I'm gonna tell you this operator is for OR operation. And as I told you before, OR operation can be used if you want to set some bits. Okay. So if you have a byte here, guys, and I want to set this bit, and I don't want to change the other bits, what can I do? I can put here 1, okay, and then I can put zeros everywhere, and then I can do OR operation. Once you do that, here you are going to get 1, because 1 or any bit you get 1, and then 0 or any bits you get the same bits again, right? So here So what I did here, I put here 1 in this bit and I didn't change the other bits. Okay, I explained it as simple. It's not something new. I'm using here in C. So how can you do something like that in C? So I can say port B is equal to port B or 0x, for example, 40. Any number, right? So here I selected 40. So because I put 40, this means 0 is 0, 0, 0, 0, right? 4 means 0, 0, 1, 0. So here I'm going to set this bit, which is bit number 6, right? And then all the bits are the same, right? So I'm going to use an instruction like this one to turn the LED on to set one bit. Again, this instruction you can write it this way. This one or this one is exactly the same in C language, just compact. Okay. Same thing here, guys. I'm going to explain. This operator means XOR, and as I told you, in XOR, XOR is used if you want to toggle or we want to flip some bits. So if I do something like that, guys, port B is equal to port B XOR 01. Again, this is hexadecimal. So 01 means 4 zeros and then three zeros and then 1. So this is going to be the first bit or bit 0. So this one is I'm going to toggle bit 0, right? Because as I said before, in case of XOR, 0 means no change, 1 means toggle. So if I do something like that, guys, if you look at this one, so this one has 0, 0, 0, 0, 0, 0, 0, 1, right? So if I do something like that to port B, this is port B. So here I'm gonna flip this bit, right? And then we change to other bits. That's what I explained before. This is how C language. This is how XOR works, right? So 0 XOR any bit, you get the same bit again. 1 XOR any bit, you flip the bit. Okay. This operator, as I told you, this is one's complement. So let me explain what this instruction is doing. Okay, guys. This is port B is equal to port H, the port H, but after you do the one's complement of port H, right? So what's going to happen here? I'm going to read port H, and then I'm going to flip all the bits, and then I'm going to store the result in port B. So what is port H? For sure, I'm going to explain later what is port H, but if you go to the port H, this is where you connect, the switches, right? So I'm going to read the switches, I'm going to flip them, and then I'm going to write them on port B to show them on the LEDs. This is what this instruction is doing. So what this instruction is doing, I'm going to say, read the value of port H, calculate the ones complement of this value, and then store the result in port B. Please don't be confused. This instruction is going to change port B because you know in C language equal, if what comes before equal, this is what will change, right? But this one is not going to change port H. Okay, so you just read the value of port H, and then you complement this value, not port H. So this one doesn't change port H, but actually it's going to change port B. Now I'm going to explain how can you do a shift right and shift left. So I can do something like that. I can say shift port B, shift it to the right 3 times, right? And then store the result in port B. Again, guys, don't be confused. When I shift here, actually, I'm not shifting port B itself. I'm taking the value of port B, and then I'm going to shift it 3 times, and then the result has to go to port B. But this one alone is not enough to shift port B, right? This is for shift right. I can do this switch for shift left. Again, and the number we put here, this is how many shifts do you want to make. We didn't have this option in assembly, because in assembly, if you want to make 3 shifts, you have to write the instruction 3 times, right? But here in C, you can write a number here, how many shifts you want. So if you want to shift only 1 time, you can just put 1 here, right? Again, this one can have, this one has a compact format like this one. Also, this one has a compact format like this one, okay? The other thing I want to teach here, guys, relational and logical operators, okay? You are familiar with equal, not equal. I'm going to give you example now. Greater than or equal, less than or equal, and then I'm going to give you about and or not. So what is the difference between this and double ampersand and only one ampersand I explained before? What is the difference? Big difference, very big difference. This one is bit by bit, right? So you have two bytes or words, whatever, bit by bit, operation bit by bit. But this one, as you will see right now, this one, if you have two condition, right, and I want to make like a bigger condition, like if the first condition is true and the second condition is true, this is or. I'm going to give you example now to understand better these operators. So here I can say if E1 is equal to E2, so execute statement 1, right? So here, this is a condition if equal. So double, you should understand what is the difference between double equal and only one equal. One equal is used, as I did before, for assignment here. So here, you do some computation and you assign the result to this one, right? But the double equal is used for a condition, to create a condition. So now I have a condition. If E1 is equal to E2, you execute the body of F. In this case, the body of F has only one statement, as you see here. So in this case, you may not need braces. If you want to put braces, that's okay. It's not gonna. It's not. You don't need if it is only one line, one statement, right? If it is more than one statement, you have to use braces. If you want to use braces all the time, that's okay, no problem. So let's see another example here. This not equal. So if E1 does not equal E2, we're going to execute statement 2, right? Or the body of F. Same thing. If E1 is greater than E2, if E1 is greater than or equal E2, if E1 less than E2, if E1 less than or equal E2, right? Now, this is what I told you guys, complex condition. What this means? I'm going to tell you what this means. For example, if you look here, guys, now I have two conditions. This one condition and this one condition, right? And then I want to execute the body of F if the two conditions are true, right? So the first condition, if I is greater than 0 and I is less than 10, right? So this is two conditions, and I want to execute the body of F if the two conditions are true, okay? This is for or, okay? So I'm going to execute the body of F if at least one condition is true. So if I is greater than 20, okay, that's enough. At least I need one condition, right? But in case of and, the two conditions should be true to execute the body of F. But here, at least one of them should be true. If both, it's okay. It's more than what I need, at least one, right? So if this one is true, I'm going to execute the body of F. If this one is true, I'm going to execute the body of F. If both of them are true, okay, that's perfect. That's all more than what I need, okay? Anyway, so also we have something like that, not. So not is used, maybe it's rare to use it, but you can learn it as well. So this is not. So here, not is actually, this is a condition. If this condition is true, not is going to make it false, right? If this condition is false, not is going to make it true, right? And then for sure, I'm going to execute the body of F if everything here is true. So in this example, I'm going to execute the body of F, right? If this condition is false, because if this condition is false, right, this one is going to make it true. And if everything here is true, I'm going to execute the statement 9. So this one is similar. If this condition is false, means I does not equal 2, right? Anyway, so the other thing I want to talk about here, and we are going to need it later, guys. If you look here, as I explained before as well. So as I explained in C language, you can also, if you want to check some bits, you remember when I explained in chapter 2, how can we check some bits? One way to check some bits is by using AND operation. For example, I want to check this bit. For example, what can I do? I'm going to use AND operation. The bit I want to check, I'm going to put 1 under this one, and then I'm going to put 0 everywhere. Okay. And as you know, for example, this one has P0. B0 and 1 is B0, right? And then 0 and anything is 0, right? So we have 0 here. So the result here, and then I'm going to look at the result. it's the result. So if the result is 0, what it means? It means this bit is 0, right? If the result is 1, what it means? It means this one is 1. I'm going to look at the whole byte. This is how can we check some bits. So again, the bit you want to check, you can just put 1 under this bit, and you can put zeros everywhere, and then you can do AND operation. If the result is 0, that means this bit is 0. So how can we do something like that? That's what I'm explaining here, and there is a trick here. I want to it's something I feel like it's very weird in C language, but you should learn it to avoid making mistake. Look how I'm gonna do it. Look here, guys. I'm gonna say PTH and number 2 if it is equal to 2. Okay, so you know what I did? I'm gonna tell you what I did. Okay, let me. So this is PTH, as I told you guys. So I'm going to do AND with number 2. This is number 2, right? And then the result, this is B1, right? B1. So the result should be 0, B1, 0, 0, 0, 0, 0, 0. So this result, if B1 is 0, should equal to 0. Otherwise, the result should equal to 2 because 0, 1, right? So here, based on the value of this bit, I'm checking this bit. Based on the value of this bit, everything can be 0 or 2, right? So here, I want to execute the body if this bit is 1, which means the result should be 2, as I did here, okay? However, if you do this way, it's not going to work. Why? It looks okay, everything like okay. I'm going to tell you something is a little bit weird in C language, but this is how it is. So in C language, you know, if you have an equation, there is a certain order for the operation. So C language should do like multiplication before addition and so on. So here something very weird in C language. So here we have this operation which is AND, and we have equal, right? This is check. We check if it is equal. Well, actually, C language, this equal has more priorities in this AND. So what's going to happen? Well, C language is going to do this part first, right? It's going to check if 2 is equal to 2, and yes, 2 is equal to 2. So the answer is 1. 1 means yes. Okay. When there is a condition, C language calculates this condition. If it is true, it puts 1, right? If it is false, put 0. And now, so this one will be done first, number 1, right? Number 2 is going to do AND operation between BTH and number 1. And now if the result is 0, that means false, right? Otherwise, it is true. So for sure, that's not what I want to do at all, right? So what I want to do is something completely different. So what you want to do, I want to do this operation first, right? So this one should be done first. And then I want to compare the result with 2. That's what I want to do, right? To do that, guys, please don't. I know it's a little bit, I feel it like somehow weird, but anyway, so you can use here parentheses as I did here, so that you can force the C language to do this part first and then compare to this one. Okay, guys? Anyway. So now I'm going to explain how can you do flashing LED as we did before. If you look at the pseudo code here, it's almost the same thing as we did before. You need to do configuration. You need to disable 7 signal. You have to enable the LEDs, and then you have to pull high, wait 1 second, pull low, wait 1 second, and then go back and repeat again. Okay, same thing. Okay, but here I'm going to use C language instructions. So let's see how I made it. Okay, look, first of all, guys, in C language, we are going to include this file. This file has definition for different constant values. So we are going to use this one. This is nothing is new. This is exactly similar to the same thing as we did in assembly, right? The other thing here, also you have to write this instruction. This instruction, this is where you define the number of your processor, right? Because code word can be used for different numbers, right? So here you have to write, you have to tell code warrior what is the kind or the number of your processor. So anyway, you you have to include this file this way. You have to use this instruction this way. So your program start with main. As you know, in C language, we have a main function. When you run your program, you run the main function, and then main function can call any other functions, but other function cannot call the main function for sure. So this program, you can find it in the course website, guys, under this file here. This is the name of the file. So let's see how can we do programming. If you look here, guys, what I did, this is exactly similar to what I did before in assembly, but here I'm using just the C language instructions. So for example, DDRB, data direction register for port B, is equal to FF. Okay, so here you configure the whole port as output FF, right? DDRJ, okay, 0xFF. So here you configure the whole port output. Okay. Here also DDRP 0xFF. Here you configure the whole port output. Okay. Someone can tell me, so why, for example, here in DDRJ, why you configure the whole port output? Maybe I'm using because you know here I also need BG1. I'm not going to use the whole port. I'm going to only use BG1, right? What if I'm using the other pins input? Okay, for sure you should not do this way. I'm doing this way here in this program because I don't care about the other bits, because I only need BG1, right? So, but if you want to be more specific or you want to be more accurate, and maybe this is better than what I did here, you can do this way, guys. I can say DDRJ is equal to DDRJ, right? And then I wanna set BG1. Sorry, bit number 1. I wanna set. I told you before, if you wanna set, you have to use OR operation. So I can use OR, and then I can say 0B, which is binary number 0000, and then 0010, right? So if you write this instruction this way, by this way you can configure only one bit. Same thing here, guys, for port P. If you just want to manipulate, here also I need PP0 to PP3, right? So what I can do this way, guys, I can say DDRP is equal to DDRP, right? And then I'm going to say OR, and then I'm going to say 0P, and then 0000 1111, right? Because I wanna configure these 4. Okay, don't forget 0. I'm not gonna change. I'm gonna only manipulate these 4 bits. Okay, guys. Again, so you can do the same thing here if you wanna. So after I did the configuration, now I'm gonna enable. So here when I enable, I put 0 everywhere in port J. Again, here it doesn't matter because I'm not going to use the other pins for port J as I explained, but you can only manipulate BG1, right? You can only manipulate. Same thing here for PTB, right? By the way, this PTB may make problem to us later, okay? Why? Because as I'm going to explain later, guys, as you will see later, port P, the first 4 bits, PB0 to PB3, they are used to enable 7 segments. We have 4 7 segments, right? But the other bits here are used for RGB, LED, right? So if you write something here on port B, if you are using RGB LED, so actually you are gonna also write here. Okay. So in this case, in such a case, or in this case, you should only change the bits you want to change. Okay, not everything. Okay. So anyway, that program should be here, guys. While 1, this is how I create infinite loop. While 1, and then this instruction here is called LED underscore on. This is a function in C language, and then so this one can turn an LED on, and you have to give me the number. Which number? So this is the function here, guys. So this one is going to turn LED number 0 on, right? This is just a function. And then we have Msc delay. This one is similar to delay YMS, but this is the C version of this function. So here, this one is going to create a delay for 1000 milliseconds, right? Which is 1 second. LED off, right? Also here in Msc delay, you are going to wait 1 second. So this one is going to turn the LED off, and you have to tell me which number. So here in this number, you have to give us a number here from 0 to 7, right? Because we have eight LEDs, right? So here I turn LED number 0 on, and then I wait 1 second. I turn it's the same LED number 0 off, and then wait 1 second, and then keep repeating. Okay, guys. So now we have several functions. I just used them. One more thing I want to explain here, guys. Look, you can, first of all, let's look at this one first. LED underscore N of 00x1. Here you turn LED number 1, you turn it on, right? Instead of writing it this way, you can actually write it this way in C language, right? So you can write a function, or you can write it as a port this way. Both are okay, right? So if you like it to be this way, port B should equal port B, or this one, that's okay. If you want to use a function also, that's okay. Same thing when you want to turn the LED off, guys, you can use a function, or you can use port B. You can change port B this way. Both are also are okay, right? Same thing when you do the configuration, guys. When you do the configuration, you can, that's what I did before. You can also, instead of using all this instruction, we have also two functions. You can just use them. One is called segment 7 disable. So this one is going to do the configuration, and it's going to disable the 7 segment. So this one is going to take care of data direction register B is going to take care of also is going to take care of this one. So it's going to disable the 7 segment, disable the it's going to also disable the 7 segment, and then LED enable. So again, guys, what I want to see here, this is important slide. Why it is important? Because I want to tell you here, you can use functions in C language, and also use function as I did here, or you can use instruction. Okay, both are okay. However, I want you to understand something very important, guys. This, what I did here, okay, this is more like low level programming, more like assembly, right? And here, this is more like high level. Why? Because the main purpose, the main advantage, or the main purpose of C language, that you can be very far from the hardware, right? If you want to do something, just use a function, and you don't need to even to know where the details. You don't need, you may not need to know if the LEDs are connected to port B or A or H. You may not need to know the details, okay? Because if the details are hidden in the function, just use functions, okay? So again, in exams, in final exam, project, anything, if you like this one, I'm okay. If you like this one, I'm okay. But you should understand, okay, that what is the difference between low level and high level. So I wrote it, yes, I wrote it in assembly, but it looks like, yes, this is, I'm not saying this low level, guys. I'm not saying that. I'm writing assembly, right? Sorry, I'm writing C language. I'm saying the style here is similar to low level, right? But the style here is more high level. You are far from the hardware. Okay, guys? Anyway, the last program I'm going to teach today is this one. If you want to send serial communication, as you see here. So serial communication means, guys, you have one pin. So if you one pin on the microcontroller. If you look at this pin, you see here, guys, it is 0 for some time, and then it is 1 for some time. So you send the data serial. So every sometime, this time, for example, it can be 10 milliseconds, it can be more, it can be less, whatever it is. So every sometime we output a certain bit by bit. Okay, guys. So this is the information I want to output in one pin. Which pin? BT0. Port T pin 0. So I want to use BT0 to see this information. I want to see 0, 1, 0, 0, 1, 1, 1, 1. It should be here somewhere. Yeah, it's 1, 1, 1. This one is different. Sorry. So it is, yeah, 0, 1. Yeah, 0, 1, 0, 0, 1, 1, 1, 1. Okay. So this is the information. Okay. This is the information. However, in order to be able to see this information, I want you to repeat it. So I'm not repeating it because I have to repeat. No, if you use this program for communication, serial communication, actually it depends on the protocol, but usually you are not going to repeat. Okay, I'm repeating. So I'm repeating the same information so that you can see it in the scope. Because if you don't do that, if you look here, guys, this part from here to here is similar to this part from here to here, right? I'm just keep repeating it. I'm repeating it so that you can see it on the scope. If it's only one time quickly, you will not be able to see it, right? So that's what I want to do. I want to output this information on BT0, and then I want to repeat it. Okay. So how can you do that? I'm going to tell you how. Very simple. So now I have a byte, this byte here, with this information. Okay. So all what I'm going to do, guys, I'm going to do the following, right? So I'm going to shift right. I'm going to shift left. When I shift left, this last bit is going to go to the carry, right? As you know. For example, this is bit 7, so bit 7 is going to come here. And then after that, I'm going to ask the carry. If the carry is 1, I'm going to check the carry. If the carry is 1, so I'm going to output 1 on BT0. If the carry is 0, so I'm going to output 0 on BT0. So I'm going to see what is the value of the carry. Based on this value, I'm going to output 1 or 0. So that this bit, the value of this bit, I'm going to mirror, I'm going to reflect or mirror it on BT0, right? If this bit is 0, I'm going to output 0. If it is 1, I'm going to output 1. Is that okay? So that's what I'm going to do right now. So every time I'm going to shift, and then after you shift, this one bit is going to go to the carry, and then based on the value of the carry, I'm going to output 0 and 1 to BT0. Okay. However, there is a problem now also. What is the problem? The problem is after 8 iteration, you are going to get 0, 0, 0, 0. Okay. That's not what I want to do, right? So what I want to do after 8 iteration, I want to get the same number again because I want to repeat. Okay. So what should I do? What I'm going to do after you output a number here, guys, I'm going to copy the number back here. I'm going to put it back here, right? So that it becomes like, guys, this is a byte, so it's like rotate this way. This byte, this value is going to go to the carry, and then I'm going to return it back to here, right? So that after each iteration, I'm going to get the same number again. So let me show you how it works. So as you see here, guys, we have this is the information I want to output, okay? And we have a byte. I'm going to call it P, and then I'm going to write this information in P. For sure, as I said many times, I cannot use BT5, BT0. I have to configure this one as output. That's what I did here, right? So your program will be here all the time, from here to here. Your program is going to be loop here all the time, right? So let's see how it works. As I told you, number 1, you shift left for B. This number 1. Number 2, you are going to check the carry. If the carry is high, I'm going to come to here if it is high, right? So what should I do if it is high? Number 1, you have to output 1 to BT0. That's what I did here. You have to output 1 to BT0, right? Number 2, because it is high, because this one was 1, I got 1 here, so this one I have to write it back here, right? So that after each iteration, I'm going to get the same number again. That's what I said. So I did bit set for B and 1. Is that okay? Now, if it is low, so if it is high, I'm going to come this way. If it is low, if the carry is low, I'm going to come this way. So what should I do if the carry is low? As you see here, guys, or if the carry is 0, what should I do? As you see here, I'm going to do this 2. If you see, guys, here, this is similar to this 2, right? But this set here clear, right? So if the carry, here, I'm going to come here. If the carry is 0, I'm going to come to here if the carry is 1, right? So if the carry is 0, what I'm going to do, I'm going to go to BT0. I'm going to put 0 in BT0, as you see here, right? Also, P, I'm going to put this 0. I'm going to put it back here, this 0, as you see here. Bit clear. Okay, I'm going to put it here. By the way, you may not need this instruction, by the way. You know why? Because when I shift, I'm going to put 0 anyway. So if the carry is 0, I don't need to go and write it again, right? I put it here so that to make symmetry, to be symmetric. So this instruction are identical to this instruction, but actually you may not need this one, right? Because when you shift, you actually already put 0. So if the carry is 0, I don't need to go and write 0 because it's already 0, right? Anyway, so that's it. So I'm going to keep doing it. After each iteration, I'm going to get the same number again. So you got what I'm saying? So after each iteration, I'm going to get the same number again. You can put here some delay. So using delay YMS, so you can make here some delay, because when you output 0, I have to keep it for some time. It cannot be too short, right? This depends on the protocol, communication protocol, but you have to keep it for a certain time so that the receiver should have enough time to receive the data. You got what I'm saying? So you can, so that's why you can see here, I select a certain time here, 10 millisecond or whatever, right? Here it's 4, right? 4 bits here. Yeah. Okay, guys. Thanks very much, you guys, and hopefully this time the recording is better. I'm sorry for what happened, but I don't know. Anyway, so thanks so much.